Today's talk is going to focus on our HaLCon instrument for IgG or antibody titer measurements. What does HaLCon do? How can it benefit your science? HaLCon is the first purpose-built solution or purpose-built instrument for real-time IgG titer monitoring. It has a wide dynamic range from 0.1 all the way to 10 grams per liter. It's meant to be used by the process development scientists who don't have a lot of expertise in chromatography. There's no specialized training required. It's fast, very easy to use, and gives accurate and reproducible results for antibody concentrations. It complements HPLC testing. It agrees very well with HPLC results, and it is compatible with automated sampling methods. How does it work? You take your sample from your bioreactor, you generate a cell-free sample either by spinning it or filtering your sample. You then inject that sample onto HaLCon. That's the last manual step you have to do. At that point, HaLCon will prepare the column, HaLCon will load your sample onto the column, HaLCon will wash the protein A column, HaLCon will then elute the antibodies off the column, quantify it, and return a gram per liter concentration number, all within 5 minutes without any hands-on steps required. It's really meant to be very easy with a minimal training burden and give a very fast quantification result. To show a little bit of data, on the left is a bioreactor run. We're taking multiple samples across the 19-day run. We're running those samples on both HaLCon as well as on a traditional HPLC with a protein A column attached to it. You can see there's a very good correlation. There's very good agreement between the concentrations on HaLCon and the concentrations you're getting off the HPLC protein A. This shouldn't be surprising because both tools are using the same technology. HaLCon's just a much easier, user-friendly version of HPLC and purpose-built for the bioprocessing environment. On the right is the correlation graph. The correlation graph should not surprise anybody based on how well the two curves agree with each other. What are some of the challenges in the bioprocessing environment for measuring titer? The big one we hear from a lot of people we talk to is that the instrumentation available to them is not fit for the purpose. It's not set up for protein titer measurements. Sometimes there's time-consuming sample preparation. Sometimes, unfortunately, the solutions aren't particularly accurate or don't have the dynamic range that's required for measuring from low concentrations early in the bioreactor run to those high concentrations you're getting closer to the end of the run. Sometimes there's a big training burden, or sometimes it's a large multifunctional instrument, which just requires a lot of reagents and adds a lot of expense to doing that analysis. If you're not doing real-time analysis, you're looking at retrospective. The challenges with retrospective or batching the samples at the end of the run is it prevents the ability to have any real-time corrective actions. You can't get in the morning, grab a titer, and react to what you see. If the titer's lower than you expected, if the culture's going off the rails, you need that data point right then and there to be able to react to it. If you're doing a DOE, it's really nice to be able to populate the DOE with all of the data that you need at that time so you can really understand what's occurring. Also, retrospective analysis isn't really compatible with the PAD initiative. PAD initiative is all about getting critical quality attributes, getting data during the run so you can have better control and better understanding of what you're seeing and what's happening in your bioreactor or your shake flask. Last, but certainly not least, to talk about HPLC. Many people tell us that there's a long turnaround time to get results from their HPLC from the bioanalytical core or the core facility that's running the HPLC. Sometimes it's 24 hours in a best case. We hear people say 36 hours. We've even had a couple of people tell us it can take up to a week to get their data back if it's not a stat sample, if it's not high priority results. In cases where you're waiting, samples have to sit, batches have to sit. It can delay the analysis. It can delay any downstream processing that's going to occur. Equally challenging if you wanted to bring an HPLC directly into the process development lab, it requires expertise. It requires method development. It requires a lot of prep work and specialized training. It's just not the best use of time or the scientist's time in the process development group. How does HaLCon work? HaLCon is based on two consumables, so two different consumables that you put on the instrument, which means there is nothing that the scientists at the bench have to prepare. There's an analysis module, which doesn't require any tools to install. It's a simple insert and turn to click into place. You get feedback that you know it's been clicked into place and appropriately loaded. There is a reagent pack that you put on the instrument. The reagent pack contains the two buffers that are used for washing and eluting the antibodies off of the column, so the scientists don't have to spend any time making their reagents. Also, because everything is set up to run on HaLCon, it really makes for a very user-friendly experience, and it minimizes any downtime or any failures associated with reagent problems that can plague an HPLC. What are the workflows for running on HaLCon? It's 4 easy steps to get going. You walk up to the instrument, it has a touch screen on it. You enter your sample identifier. You select which cal curve you want to use for quantifying your samples. You then inject your sample directly into the HaLCon instrument. You hit the start run button or the run sample button. And at that point, everything happens on its own. The instrument takes over, it preps, it loads, it washes, it elutes, it quantifies. 5 minutes later, you have your data point. If you have another sample, you can inject another sample immediately. If you are looking at lots of samples from multiple bioreactors, multiple grab samples from that day, we are compatible with auto samplers as well. There's also online sampling tools that work if you do want to work in an online automated fashion. A couple of other quick data points. This is, again, looking across a multi-day run. It's a 19-day run. In this data set, we are comparing HaLCon with Protein A HPLC, as well as BLI, or biolayer interferometry. What we're looking at is just daily cell-free samples. For HaLCon and for the Protein A HPLC, there were no dilutions required. There is strong correlation, again, between HaLCon and Protein A in the blue and the green lines. You can see the BLI data is the red line on there. There are slightly larger fluctuations on the BLI as compared to the other two. Most likely that's due to the fact that BLI requires multiple dilutions when you are getting to some of those higher concentrations, those higher antibody concentrations in there, and that can lead to variability. One last quick data set to share. When comparing titer and cell viability or cell density, you really want to get both data points to completely understand what you're looking at in your culture. In the left graph, you can see in blue the antibody titer. It is increasing across the full 19-day run that we're looking at. Interestingly enough, maybe not surprising, the cell viability does start to decrease around day 14 to 15 in this culture, but that antibody titer is still increasing. If you'd based all of your analytics, all of your culture time merely on viability, you would have lost a lot of additional antibody, which would have been produced later in that growth curve after the viability had started to decrease. Just to look at the data slightly differently, looking at max cell density, when the cell density peaks somewhere around day 12, we are at about 1.4 grams per liter. Whereas when we look at day 19, the max cell density has decreased quite a bit, but that antibody titer is now maxing out at nearly 2.2 grams per liter. So both data points, very important for understanding what's going on with your culture and for getting the maximum yield that you can from that culture. What are the opportunities? What are the advantages for doing online or at-line antibody titer testing? It allows you to make decisions earlier in the process. You can save time with process development. You can move from upstream to downstream quicker. You can harvest on time. You can really optimize some of your processes. Routine monitoring gives you more data, lets you do your DOE quicker to really get to the optimized conditions as quickly as possible. And it allows you to take daily or even more frequent measurements because you can calculate those concentrations right at that time. Certainly, last but not least, process modeling. It lets you better understand your process. The more data you have, the more quickly you have that data, the better you can look at the process and optimize that process. Wrapping it all up, what are some of the big advantages or benefits to HaLCon? It's fast, at line or online. I don't think I mentioned it before, but there's minimal maintenance. There is really no maintenance that you need to do for the instrument at all, other than changing those consumables on a predetermined schedule. The measurements can be run by anybody. You don't need one lab expert or guru as the only person who can run HaLCon. The whole team is able to run it because it's so easy and straightforward to get it up and running. And it is based on protein A chromatography, so it does correlate very well with the gold standard of HPLC.